Yeah, so those, of course you didn't have to draw these exactly the same way that I did. And nets can look differently, but we see this one with the triangles, that's for a pyramid. And then these ones with the rectangles, that's for this prism like this. Both of those vocabulary words, pyramids and prisms, though, that's stuff that you did in 7th grade. And then, yeah, finding the surface area of a sphere with the diameter. We just use the sphere formula, which is on this poster back here, 4 times pi times radius to the power of 2. Done. Here's our objective for today. I can find the volume of composite shapes and spheres. So take 30 seconds and copy that down, please. All right, a composite shape, a sphere is kind of a shape by itself, but a composite shape is where we're going to take some of those shapes that we've seen before, spheres, cones, and cylinders, and we're going to push those together to make certain different shapes, okay? Now, in addition to those, we're going to be looking at prisms as well. For the most part, we're going to be looking at rectangular prisms, although it's possible to find volume of triangular prisms as well. And now, to find, there's not really a general formula to use for these. I mean, there is, but the problem is the base of the prisms changes. So when we're looking at a rectangular prism, if it were rectangular, the formula is pretty simple. It would just be length times width times height. And within rectangular prisms is also included cubes. If it were triangular as a prism, then what you're going to do is you're going to find the area of the triangle first. So that's base times height, usually what they write, base times height, divided by 2. And then you multiply that by, I guess, the depth of the prism as well. So I'll put D right there, although usually it's H, but whatever, okay? Again, this is just reviewing stuff that you should have learned in 7th grade as well. And then, in addition to those, prisms, rectangular and triangular type prisms, we're looking also at pyramids as well. So that's why we saw those on the bell work. The pyramid is, all you got to do, it's just like the relationship between cylinders and cones. You just find the volume of the prism with the same measurements, but divided by 3. And again, this is a general formula right here, but again, depending on what type of prism you're finding will depend on what the volume of the prism would be. But again, the pyramid will be a third of that. Now, something we'll see as well on these, and this is a pretty common shape, is like an ice cream cone. An ice cream cone itself, the cone itself is a cone, of course, but then you attach usually what we're going to consider half spheres on top of the cone. And so we'll say, hey, find the volume of an ice cream cone with these measurements, with the half sphere on top being, I guess, the ice cream scoop. So as a little review, finding the volume of a cylinder is when we take pi times the radius to the power of 2, and then we multiply that by the height of the cylinder. Just a little review on this. And yeah, this one, they gave us the radius right away. Of course, remember, diameter is double the radius, or radius is half diameter. And they may give you diameter, not only in the classwork today, but in the assignment as well. So I see the radius is 21 millimeters. And then the height, they showed us right here, is 19. And yeah, this, again, is just exactly what we did last time for volume of cylinder. So I'm just going to take my calculator. I'm using the pi button. So I push pi. Let's see, pi times 21 to the power of 2 times 19, and I push enter. Now, if by chance the assignment wants an exact answer, which it may, that's what the calculator is showing me right here, is 8,379 pi. And of course, that's in cubic millimeters. Or, if we wanted an approximation, we're just going to push the double arrow button right above the enter button. And that will change this value into a decimal for us, which is probably more what we want. So this is 26,323. I'm going to round this to the nearest 10.4. And again, this is in cubic millimeters right here. So, but this is actually more of an approximation, because when we're working with pi, of course, which is an irrational number, the decimal goes on forever and ever without repeating or terminating. So it just depends on what level of accuracy you want from these values. So, but the assignment should specify what it wants, and usually, if I remember right, it wants the approximation on these. So that was a nice little review. But now we're looking at this kickboard. It's a foam kickboard for swimming. Now you'll see up here that it has two identical hand grips. It's very nice, very convenient. But again, this is what we call a composite shape because it has two of our three-dimensional shapes that have been pushed together. Now last year in 7th grade you found area of composite shapes where you pushed perhaps a triangle next to a rectangle, then found the area of the two shapes, just add them together. That's all we're doing here, but now instead of it being area, it's volume, okay? So I see on this one, and I'm ignoring the handles first, okay? We'll focus on the handle measurements, which are shown here. Now it may be hard to tell this with the drawing, but the depth of this shape is shown at 1.25 inches right here. So for me, I'm going to say that's my height of these shapes. Well, what shapes are we looking at here? Well, this first one, right here at the bottom of this one, this is a rectangular prism. Okay, so because it's got a rectangle here, but it has some depth, so it's three-dimensional, which makes it a prism. Rectangular prism. And then up here at the top, again, I'm ignoring the handles as though they're filled in. That's half of a cylinder right there, because it's a circle. It's half a circle, but it has some depth, so it's a cylinder. Okay. Now, of course, if there was a slanted edges to a point, then it would be like half a cone, but this is a cylinder because the depth is the same throughout the shape. All right. So I'm going to find the area of all these. Not the area, but the volume of these. Starting, I'm going to work from the top down. So I'm going to start with the volume of the half cylinder. All right. So I'm working with the cylinder, and I know the volume formula for a cylinder. So that would be pi times the radius to the power of 2 times the height. So pi times the radius to the power of 2 times the height. However, this is only half the cylinder, so whatever I get out of that, I just need to make sure I divide it by 2. All right? Well, did they give us any of this information, radius or height on this one? Yeah, of course. The radius right here is shown as this line right here. It's telling us, it's got the little arrow right there. It may be hard to see, but that's 5.5 inches. Well, how do we know this is the radius? Because it goes from the edge of the circle to the center, right? If it went all the way through, like this is the 11 inches right there, that's diameter. So if you wanted to look at it that way, like you notice the 11 inches was the diameter, that'd be fine. But we just want the radius, which is 5.5 inches. So I go into my formula and I replace the R radius with 5.5. And the height, remember the height here is the depth at 1.25 inches. Okay, so I go in there and I replace the H with 1.25. And this is something I can plug directly into the calculator. All right, so this will give me the volume of my cylinder. Let's see what we get. I'm using the N over D button because I have mine written as a fraction. Pi times 5.5 to the power of 2 times 1.25. I go to my denominator, I put a 2 there because remember it's half a cylinder, and I push enter. That's going to give me the decimal value right away at 59.39573611. But I'm going to round it to the nearest tenth. So right now this is in cubic inches. Now that's just the half cylinder, but I also need the volume of the rectangular prism. So a rectangular prism. Let me look at volume on these. Remember that all we're going to do is we're going to find essentially the area of that surface, the rectangle, which would be found by taking length times width. But we also have the depth on this thing, which we're going to call the height of this shape. All right? So I'm going to say, for me anyways, not that it matters because order for multiplication does not matter. But for me, the length I'm going to say is 11 inches right here. So I go into my length, I replace it with 11. What about the width? Well, I'll say that's the 12 inches right there. Okay, and again, you can see that the order wouldn't matter because it's all multiplication. So the W width, I replace with 12. And then the height, it's still this 1.25 inches. That'd be the height of that rectangular prism. So I type in there 1.25. So this is something I can just put this directly into the calculator. Let's see what we get. 11 times 12 times 1.25. Enter. I get 165. Again, that's in inches cubed. So if I wanted my full volume of this shape. Now this is the volume with the handles, right? If the handles were filled, this would be the volume. So I take these two values and I'm just going to add them together. 59.4 plus 165, enter, and I get 224.4 inches cubed. All right, that's the volume with the handles, but I still need to find the volume of the handles. Now there's two of those handles. That's important to know. So volume of, this is one handle right here, right? This is the volume of one handle. Well, if we look, let's take a closer look at the handle right here. And we can kind of see that it's made of two different shapes right here. So it's a composite volume, or composite area if you want. And remember, the depth of this is that 1.25 inches. So it doesn't show it on this diagram, but we should know that its depth is 1.25. Well, what two shapes am I looking at? Well, this first one right here, that's a cylinder. It's a half circle, which makes it a cylinder. Now, if you combine it with this other half circle right here, it becomes a full cylinder. And then we also have this rectangular shape right here, which means that we're looking then at a rectangular prism with a full cylinder, even though it's been cut in half in two parts. Now, this is one handle, though, so whatever we get from this volume, these two volumes together, we're going to have to multiply that by 2. Okay, so this, but for now, I'm just finding the volume of one handle. Let's start, I guess I'll start with the rectangular prism. Rectangular prism on this one, okay? And let's go back. So, the rectangular prism. So, we've already found the volume of one rectangular prism. And that is length times width times the height. So, what lengths do we have on this one? This one, I see the 2 inches right there. So I'm going to call that my length. Now, it doesn't give us directly either of the two other values. I mean, we know the height. We should know the height, the depth of that foam board, which is 1.25. Well, what about the width? Well, here's the thing, is the width is this full length right here. Let's see if I can draw that better. This one right here. Well, that's the diameter of that circle, and it's already given us the radius of that circle. So if I wanted the diameter, I'd take that radius, 0.6, and multiply it by 2. So that would be 1.2 inches of diameter, which is, again, the width of the prism. So this length right here is 1.2 as well. So let's put 1.2 in there as my width. And then I can just put this directly again into the calculator, which will give me the volume of the prism. So 2 times 1.2 times 1.25. Enter. I typed it in wrong, but it should be 3, right? 0.25. There we go, 3. So the volume of the rectangular prism right now is at 3 cubic inches. Now remember, that's empty space in the foam board, so whatever we get as our final volume has to be subtracted from the total volume of the foam board. But that's just the prism part of it. Now we need to find the volume of the cylinder. All right, well, volume for cylinders isn't too bad. We know that it's pi times the radius to the power of 2 times the height. And it shows that the radius, again, we've already seen it, at 0.6. So I'm going to replace my radius with 0.6. And the height, again, that's just the depth of the board, which we already know is 1.25. So I put this in the calculator. Pi times 0.6 to the power of 2 times 1.25, enter. I get 1.413716694. Rounding to the nearest tenth, I'll make this a 1.4. And again, that's in inches cubed. So I need a little bit more space on this. Let's see. So the volume of one handle, the full volume, is where I take the volume of the prism, there in green, which was 3, and the volume of the cylinder, 1.4, and I just need to add these together, which shows is 4.4. Now again, this is the volume of one handle. We need 2 handles, so I just need to multiply that by 2. So that would be 8.8 cubic inches. So let's go back to the full picture here. So over here I've got the volume of the handles, volume of the full shape with the handles filled in orange, and then I got the volume of the 2 handles. So again, we're going to take the volume of the full shape, the full foam board with the handles filled in, 224.4. And I need to subtract the 2 handles out of that because again, they're empty space, so they're not actually part of the volume. So I'll just put that in the calculator if you need to, which I need to. So 224.4 minus 8.8, and this gives me the volume without the handles, which is what we want. And I get 215.6, again, that's in cubic inches right there. But yeah, that would be considered our final answer on this one. Now, based on what we did last time, really all this is just a combination of, what was it, 1, 2, 3, like 4 different volumes, and then we combine them all, right? Or we uncombine them, if you will. But the process is pretty much the same. You just have to be able to recognize what shapes you're dealing with: cylinders, prisms, and again, you'll see some pyramids and other types of prisms on the assignment. For this problem, we'll need the volume of the shape, and we just found it, 215.6 cubic inches, right? Now this one says 1 cubic inch of foam weighs about 0.007 pounds. How much does the kickboard weigh? Well, that means every one of these cubic inches is this much in weight, 0.007 pounds. Which, if we go back, this should take us back to the foundations of multiplication. It tells us how many groups of something else there are. In this case, there's 215.6 groups of 0.007. So that means I'm going to multiply these two values, 215.6 times 0.007. Of course, we're just going to put it in the calculator. And this will be the weight of this kickboard. Now, of course, that's 1 cubic inch of foam for 0.007 pounds. So if you prefer to look at that as a unit rate, you can. You should get the same answer. So for me, my calculator is showing 1.5092. And again, this would be in pounds. But I mean, it's going to round this to the nearest tenth. I'll say it's 1.5 pounds. And again, the assignment should specify how accurate it wants that value. All right, here's the volume of a shape. Well, 2 shapes actually. We got a cylinder that's stacked on top of a prism. So I'm going to start with the cylinder. Remember, we're just going to add the 2 values together. And yeah, I'm going to start with the cylinder first. That's a pretty familiar shape right there. And if I wanted the volume of a cylinder, I'm just going to take pi times the radius to the power of 2. And I'd multiply that by the height. Well, the radius on this one, it's not shown directly, but it did give us the diameter. How do we know that's diameter? Because it's the red line going all the way through the circle, through the center, by the way, which is important. So if I want the radius on this, all I need to do is take the diameter, which is 4, and divide it by 2. So that'd be 2 inches for my radius. So let's go back to the formula and replace r, the radius, with the 2 inches we just found. So 2. And then the height shows at 4 inches. So let's replace the h for height with 4 inches. Well, once again, let's just plug this into the calculator, which will then tell us the volume of the cylinder portion of this composite shape. So I type in pi times 2 to the power of 2 times 4. Now again, you may get the exact value at 16. I'm going to assume that we want this rounded to the nearest tenth, so I'm going to push that double arrow button, which shows me 50.26548246. Rounding to the nearest tenth would be 50.3 in cubic inches. So that's our cylinder. Now let's look at the prism volume. Now this is a rectangular prism. In fact, it's a cube. How do we know it's a cube? Because all the lengths, the edges are the same length, 5 inches, 5 inches, 5 inches. So, I'm going to just call it a cube. And to find the volume of a cube, all we need to do is take the side length, here at 5 inches, and raise it to the power of 3. So this gives me a volume of the cube at 125 cubic inches. Now that's nice, it gets us pretty close to the answer, but yes, we do want the total volume. So we're going to take the volume of the cylinder at 50.3 cubic inches. I think I do that better. And the volume of the cube, which was 125. And we just need to add these together. That's 175.3 cubic inches. It's a decimal right there. And that's completed. So this problem essentially becomes like two different problems from the last section of this unit, but we just did it in one problem, just combining them. All right, now this is a diagram of a cone. Now it's given us a couple measurements here. One of them we do not need. And this is an ice cream cone. And yes, at the bottom here you see, think of the scoop of ice cream. This is the scoop portion that goes on top of the cone up here as a half sphere. Now notice the radius is different than the cone as well. That's crucial because we're saying that the ice cream, and this is what you'd want, right? A little bit extra hanging over the edges. And that makes it a nice ice cream cone. And we also have the volume formula, and again, it's not really necessary that you memorize those. It's on posters in the classroom here. But we got two different shapes. Okay, and right down here it did specify that it's half a sphere. And again, I prefer to work my way down. So I'm gonna start with a half sphere first. And this is the volume of the half sphere. All right, well, the volume of a sphere. Remember, I write mine just a little bit different on this stuff, but I do want the volume on this. And so I write it as a fraction, 4 times pi times the radius to the power of 3, all over 3. And do we have the radius of the half sphere? Well, yes, we do. It's this radius down here told us was 3. So I replaced my radius of the half sphere with 3. But also, I need to remember that it's half a sphere, right? So what I need to do with this information, the volume of that would be a full sphere, what I have right there. I just need to divide it by 2. And I can type this in exactly like I see it in the calculator. So I'm going to use the fraction function to type in the formula of the full sphere. So n over d, then I type 4 times pi times 3 to the power of 3. And then I go to my denominator, I type in a 3. Now I get out of the fraction here, and I type divide by 2, enter, and it's going to give me 18 pi. Remember, it'd be nice to have this as a decimal, so I'm going to push the double arrow button. And it gives me 56.548666776. Rounding to the nearest tenth, that'd be 56.5 centimeters cubed. So there's our half sphere volume. But then we have a full cone at the bottom. So let's combine this with the cone volume. So the volume of a cone, pi times the radius to the power of 2 times the height of the cone. But remember, it's just all divided by 3. Cone is a third of a cylinder. And yeah, remember the numerator here is the cylinder formula for volume of a cylinder. Now again, these two information right here, now this is what we call slant height. That's more for surface area. So we don't actually need this measurement right here, 11.5. What we do want here is the height, which is shown as 11.2 centimeters. So I'm going to go into my formula, and I'm going to replace the height with that value, 11.2 centimeters. And then the radius, yeah, that was given up here, the 2.5 centimeters. Again, that dashed line only goes from the edge of the circle to the centers, so it's just radius on that. So let's go ahead and replace our radius with 2.5. And I'm going to type this into the calculator. Let's see what we get. And whatever I get will be the volume of the cone. So n over d for me, I'm writing it in as a fraction. Pi times 2.5 to the power of 2 times 11.2. In my denominator, I got a 3. I push enter, and I get 73.30382858 on mine. Rounding to the nearest tenth, though, it would be 73.3 centimeters cubed. Now I want the full volume of this ice cream cone. So I'm going to take the volume of my half sphere at 56.5 and the volume of the cone at 73.3. And I'm just going to add these for my full volume. Let's see, 5 plus 3 is 8, 6 plus 3 is 9, 5 plus 7 is 12. So 129.8 cubic centimeters. And that'd be my final answer on this one. But yeah, this is some volume formulas we may need. And remember, for prisms, it's like this: length times width times height for rectangular prisms. Specifically, remember for triangular prisms, it's just find the area of your triangle and then multiply it by the depth or height of the object. And then if you got some kind of pyramid, you just take whatever the prism values would be, but divide by 3, okay? Again, that's the same relationship that cylinders and cones have. Cone is just a third of a cylinder. Pyramids are a third of prism values. So there's our objective again. I can find the volume of composite shapes and spheres. Spheres are shapes too, so maybe there's a slight redundancy there, but 3-dimensional shapes specifically.